Okay, in this video we're going to be looking at solving quadratic and cubic equations using TI-Nspire CAS. First of all, a quadratic equation with real coefficients can have two real distinct roots. That happens when the discriminant is positive, in which case the graph of the function would cross the x-axis twice. Another possibility is that we have one repeated real root, and that's where the graph touches the x-axis, and in this case the discriminant is 0. The third case, when the discriminant is negative, is that the roots consist of one pair of complex conjugates. Okay, so let's look at an example here. Let's find the sum and the product of the roots of the quadratic equation z squared plus 4z plus 13. Now, I'm on a notes page here, but that's not much of a big deal or a big issue. Everything I'm typing here will be in a maths box, Control M. Now, if we try to just solve this equation, if we just go menu, or we've got to go to calculations, and then algebra, solve. If I just solve that quadratic equation, so I'll type in z squared plus 4z plus 13 equals 0, comma z, it tells me false. The reason being is that we've got to be in complex mode here to do that. So we have to use the csolve command. So to get the csolve command, we'll go to algebra, but down the bottom we have to go to complex, option number C. So here we've got solve, but when we type this in now or press enter, we actually get csolve. So I'll put that on a new line. So csolve, and when I type in z squared plus 4z plus 13 equals 0 now we'll see that we get the two roots. The roots are minus 2 plus 3i and minus 2 minus 3i. Okay, now I'm going to do another way of doing this as well. Before we do that, I just want to show you a little bit about lists and what happens with lists. So I'll just open up another calculator page. And what we'll do here is I'll just define a list. Now, a list is just a set of numbers defined in curly brackets here. So, for example, if I just say 2, 5, 7, and what I'm going to do now is I'm going to store that, so Control var, store that to say XL. And that's the list, XL. If I want to access the elements of the list, I can type XL square brackets 1. So that accesses the first element, which is 2. If I want to access the second element, just pressing up arrow and enter, 2, that gives me the second element, which is 5. Up arrow again will give me, this time I'll type in 3 here, and that'll give me the third element, which is 7. Now, a nice thing about lists is that we can add up all the entries in the list just by typing the word sum, or alternatively, getting it from the catalogue or the book. So if I type in sum XL, which is the variable, this is going to equal 2 plus 5 plus 7, which is 14. Okay? May not seem such a big deal, but we can have lots of ideas here. I'll show you what I mean by a couple of other things. If I define a function f of x equal to x squared, then if I want to have f, the function, of the variable XL, then what has that done? It's squared every element in the list. So that's quite a powerful little aspect. So every element, 2 is squared, 4 is 5 is squared, 25 and 7 is squared. All right, so let's come back to this page here. I want to add up them. I want to add up the roots of here. So I want to find the sum and the product of these roots. So if I want to find the sum and the product of the roots, rather than going csolve, I'm going to go menus, calculations, algebra, but zeros. Now, zeros is just put in the normal command zeros. That won't work again. I have to make it C zeros. So when I do C zeros of my function, of my quadratic, z squared plus 4z plus 13, C zeros does not require us to have the equation equal to 0. So I don't put equal to 0. Here I just put comma z. And what I'm going to do then is I'm going to store the results of this list to the list of complex numbers, which will be ZL. So this time, my first element is minus 2 plus 3i, so we can have lists of complex numbers. So I'm just inserting another maths box with Control M. So ZL square brackets 1 is the complex number, and ZL2 is the second root of the complex number. Okay, so to find the sum of these, I'll just go sum of ZL, and that's obviously going to equal minus 4. And if I wanted to find the product of the roots, ZL of Z1 multiplied by the list ZL of element 2. That gives me 13. Now, look very carefully at those two numbers there, minus 4 and 13. Minus 4 and 13. That is no fluke that when we do the sum and the product of the roots of a quadratic equation. So, in general, if I've got a quadratic equation with real coefficients, having roots alpha and beta, then the quadratic equation is always going to be z squared minus the sum of the roots times z plus the product of the roots. So that leads us on to solving some cubic equations now. So if I wanted to solve a cubic equation with real roots, now this is important that the roots of the equation are real. What are the possibilities for a cubic equation? Well, we can have 3 real roots, so the graph crosses the x-axis 3 times. Another possibility is that we have 1 real root and 1 pair of conjugates, so the graph crosses the x-axis once. Or another possibility is that the graph crosses the x-axis once and touches it at that point. Then that point is called a turning point on the x-axis. So we can't have 3 complex roots, provided we've got real coefficients. So let's do another one of these. Find the sum of the roots z cubed minus 5z squared plus 11z minus 7 equals 0. So we can just do a C-solve, menu, calculations, algebra, and this time we'll go to the complex number tools again, complex number, solve. So now I type in my equation, z cubed minus 5 times z squared plus 11 times z minus 7 equals 0. It's a C-solve, so it has to equal 0, comma z. So that gives me the 3 roots. Again, notice we've got 1 pair of complex conjugate roots and 1 real root. Okay, if I wanted to do the sum of the roots, we're going to see if we still get the same nice thing happening here. Okay, so now we're going to use the C zeros command. Menu, calculations, algebra, zeros, but don't only put the zeros, we have to put the C in front of it for the C zeros. And now I'm typing in my equation again, just like before, plus 11z minus 7. Now this time I don't have equal to 0 for the zeros, I just have comma z. Once again, I'll move the cursor out of there and we'll store this to a list. Again, I'll say ZL for the Z list. And if I want to add up my 3 roots, I'll type in my maths box, sum ZL. So once again, we get 5. And again, that's no fluke that that number there was minus 5. I'll leave it to you to find the product and sum of the other roots. There'll be 2 at a time or 3 at a time.